So, welcome everyone, and thank you for attending our webinar on the courses offered by the Faculty of Engineering. To start off, I'm going to expose the rationale of why you should consider choosing a degree in engineering, and mainly the reasons that are often provided are that warranted engineers are well-respected professionals, and this respect is guaranteed not only in locally but also wherever you go around the world. Engineering jobs are in fact in very high demand, both locally and abroad. And throughout the course of becoming engineers, you will learn skills that makes engineers employable in different sectors, not just in the traditional engineering sectors, but also in sectors like the gaming industry, for example, the medical industry, and so on. Engineers also have the opportunity to work in teams with other professionals, and this makes the workplace of an engineer one which is very, very interesting. For us to understand why we should become engineers, we need to understand actually what an engineer is. And for this, I always like to quote Theodore von Karman, who was a mathematician and an aerospace engineer. And he famously said that while scientists investigate that which already is, engineers create that which has never been. And it's easy for us to understand where this quotation is coming from if you consider, for example, mobile communication. Some 20 years ago, when I was sitting in exactly the same place he was sitting right now, I was months away from having my first mobile phone. When I did eventually have that mobile phone, it was one which could only send text messages or receive telephone calls and perhaps play a game of Snake. Nowadays, our mobile phones are like mini computers, having the ability to connect to Wi-Fi, the ability to receive and take videos and images, photos, and their design has been made to be much sleeker and much more comfortable to use. This came all about because engineers foresaw the need to have mobile cameras and mobile video systems, the need to communicate not just through telephony, but also through internet connection. So we see that engineers are affecting and changing the way we go about doing our day-to-day lives. So, with that in mind, let us see what courses the Faculty of Engineering offers, and let's delve deeper into these courses. So, the Faculty of Engineering offers two principal courses, the Electrical and Electronics Engineering and the Mechanical Engineering. The Electrical and Electronics Engineering focuses on the generation, distribution, application, and control of electrical energy and electrical and electronic systems. Electrical engineers can apply their scientific knowledge in fields of transport, space technology, biomedical technology, control, robotics, automation, communications, energy distribution, and even artificial intelligence. The mechanical degree covers the design, development, improvement of mechanical components and systems that make our world and lives function. Mechanical engineers can apply their scientific knowledge in fields of bioengineering, fields of robotics, the production of sustainable and clean energy, the access to clean water, aerospace, manufacturing, and nanomaterials. So there is a diversity of subjects that our students can learn through these two courses. It's important to know that both courses are 4 years long, and by the end of the course, the graduates would be eligible for the engineering world. Both courses have a very excellent reputation, both locally and internationally. In fact, the two courses are what we call accredited courses, which basically means that there are entities outside of Malta who have given the courses the stamp of approval. And this means that the quality of the courses are recognized not only locally, but also by external entities. Whichever course that you follow, both degrees prepare the engineering student with valuable skills. First and foremost would be the skill of numeracy. This can be used either for forecasting profits, to calculate the forces of a bridge, or even to send satellites in space. Basically, all engineering has to do with number crunching, using numbers to obtain designs that we need. Through both engineering courses, you will learn how to use computer skills, be it for computer-aided design or prototyping, or programming to developing new artificial intelligence algorithms. These skills will be given throughout the course, and our students will get the skills they need depending on the areas and subjects that they choose. But besides the theoretical and mathematical skills, our courses also involve quite a number of project work, which allows students to learn the important life skills, which cannot be really given through theoretical learning. And these would include planning of projects, planning of your own work, balance of quality and speed in whatever design that you're creating, how to communicate your findings, and most important of all, how to be creative in solving your problems. These last skills that I mentioned are skills that are required in the industry and are skills that are sought after in industry. So let us now look at the two different courses on offer in a little bit more depth. The electrical and electronic engineering courses is, as I said, is 4 years long, and it's divided in the first 2 years being the fundamental, creating the foundations of the course, and the last 2 years continuing to develop the student skills. So in the first year, we focus on the building blocks that are necessary to create systems that make sense from the data and the world around us. So we introduce our students the fundamentals of electronics, electrical circuit theory, and signal processing. In the second year, we delve deeper into these fundamental building blocks by looking into concepts of electrical machines, electrical power, and automatic control systems, and even microelectronics. Then, in the third year, students can focus on study units from 3 different areas, mainly electrical engineering, electronic systems engineering, systems and control engineering. In the final year, the students will have what is known as the engineering project, and this is basically the dissertation of the student, where the students are given an open-ended question, and with the help of the supervisor, will find out ways of solving this question. So what I'll be going through next is the difference between the elective study units offered by the 3 streams in the course. So if we start by looking at electrical energy, electrical energy will focus on the conversion between different forms of energy. So we all know about renewable energy sources, energy that comes from solar panels, energy that comes from wind systems, and energy that comes from the normal energy provider. So how would we be able to get all these energy sources and provide electrical energy to our homes? And not just provide electrical energy to our homes, but do it in a way that is as efficient as possible. We all know that electrical energy is expensive. It's expensive to create, and it's expensive to generate, both in terms of money, but also in terms of environmental concerns. So it's very important to make the maximum use of the resources that we have. It's also important that in our homes we have stable electricity at all times. Because otherwise our appliances wouldn't work as efficiently as we'd like them to. So through electrical engineering, our students learn the different components that make all this possible. It's also important to note that our appliances, be them if they are electrical cars or electrical light bulbs, they should be making the most use, giving us the most output with the minimal use of energy. And at the crux of all this is the basic electrical motors. So students will learn how electrical motors function and the different types of electrical motors. I've mentioned that electricity can come from different sources, and more our students are learning about smart grid systems, which are basically the different ways that we can use these different sources as efficiently as possible, and with the best cost effectiveness. If we go on to the electronic systems engineering, then here we consider smaller scale electronics, focusing on the design of analog and digital circuits. This could be in applications in aviation, so all the sensors that are used by pilots to be able to navigate their aircraft, and power circuits that can amplify small signals. We are probably all familiar with amplifiers that are used with sound, but power circuits can also be used, for example, in the medical industry, where we get small scale signals coming from the human body and amplify it to make it more readable and better to interpret. Electronic systems also focuses on high frequency circuits, and these are the type of circuits that are used for mobile communication. And we also teach our students not focusing only on the analog parts of circuitry, but also focusing on the digital circuitry, shifting from analog-based circuits to circuits that function with computer-based systems. And here we have examples such as the autofocus of cameras to the microcomputers that are embedded in satellites to be able to control the satellites once they are launched in space. Now, we obviously want our electronic devices, be they the mobile phones, our cameras, and so on, to be as small as possible and as mobile as possible. And for this, we require the use of microcontrollers, which are basically smaller computers that are embedded in our devices. And our students will learn how to make use of these microcontrollers. The last area in electronic systems engineering is the area of systems out control engineering. And here, the focus is on sensing data from the world around us and using that data to make our machines function in a more intelligent manner. This can vary from automated systems like automated packaging of bottles or foods materials to mobile robotics, focusing on things like path control and creating new pathways so that we have obstacle avoidance. To going even more in depth to the areas of transportation, where we can design systems that are what are known as smart traffic systems, which basically try to avoid the creation of traffic as much as possible, and also having cars drive around in a safe manner, avoiding pedestrians. In this area, we also delve into what is known as artificial intelligence, based through object recognition through deep learning applications. And I mentioned that we sense the data around us, and basically this involves gathering signals and interpreting those signals. And this can be signals coming from audio devices, such as musical devices, to signals coming from human bodies, such as signals coming out of our brains, our eye movement, and so on. And this now brings us to the area of mechanical engineering, so the bachelor in mechanical engineering. And just like the electrical engineering, the first 2 years are focused on giving the students the fundamentals required in mechanical engineering. And this would be the study of mechanics, material science, thermodynamics, and manufacturing machining. And basically, the student would be understanding the physics that drives these systems, the materials that are most suited for the systems that we are using, and how to produce these systems in a way that is as most cost effective as possible. In the second year, students will delve deeper into the aspect of mechanics, manufacturing systems and processes, material science and their selection. And then once the student reaches the third year, they can choose to follow study units in one of 3 streams, which are mainly the applied materials in engineering, applied mechanics and thermofluids engineering, industrial and manufacturing engineering. In the last year, similar to the electrical engineering course, the students will have the engineering project. So let's go a little bit deeper into the 3 areas. In applied materials in engineering, students would learn about the structure and properties of materials. As we know, if you have any material, there can be degradation in its form. And the materials engineer, it's important for the materials engineer to study how this degradation happens in time and what materials should be brought together to serve in a particular application to minimize this degradation. The materials engineer will also investigate the use of new materials and new materials targeted for specific application. So, for example, in biomaterials, the materials engineer would need to find out the best material to use for different applications, different biomedical applications, and investigate the types of properties that these materials would need to have. Obviously, with this comes the selection of appropriate materials and the use of materials for applications in environmental engineering, such as water purification. In the applied mechanics and thermofluids engineering, students will study the way fluids and combustion and air compression and systems equilibrium happen, and study how different systems perform under different stresses and strains. This has applications in naval architecture and biomechanics. When we talk about the flow of fluids, one easy application of that would be in the air conditioning systems, where the student will study how air flows and in order to maintain a stable temperature. This can be extrapolated not just to the cooling of a room, but to applications which require more sensitive temperature control. With thermofluids, students can study, for example, how the air flows over an aircraft wing in order to be able to maintain the height of the aircraft as it travels, and that has similar applications in wind energy generation, for example. So the way the air flows around the wind turbine to make sure that the energy generated by the wind turbine is as efficient as possible. And when we talk about stresses and strains, one can easily imagine the bridges, which are under different stresses and strain coming from their use, not just the cars or the traffic happening on the bridges, but also through environmental changes. And while it is easy to imagine mechanics as being something related to physical components, it's important to note also that mechanics can also be applied in biomedical engineering, where we use the same concept of stresses and strains and movement to understand how our body has the physical demands of our body in order to be able to create replacement systems when our body parts start to fail. For example, the classical example of having knee replacements or hip replacements. In industrial and manufacturing engineering, we then learn about the different manufacturing processes, including the digital and smart manufacturing, the use of computers to aid not only the actual manufacturing process, but also to design prototypes in a way that is as efficient as possible. We learn about mechatronics, which is basically the understanding of mechanical systems combined with electrical systems for applications like robotics. And something which is very important in today's world is the concept of quality control, which basically lets us understand the quality of the products that are being offered on the market. We are living in a digital world, and we are living in a world where everything has to be as efficient and as cost effective as possible. So the concept of smart manufacturing is very important and very applicable in today's world, because our students can learn how to make the best of the resources available to reduce waste in the generation of new products, and thereby keeping costs down and maximizing the throughput of the production line. Again, just like mechanical engineering, the classical mechanical engineering, manufacturing engineering is not applicable only to manufacturing of physical objects, but can be applied to manufacturing of human interfaces. So in the examples that we have over here, there is a robotic arm and a prototype for a leg replacement for an animal. So manufacturing engineering also lends itself well to biomedical engineering applications. With that description of the different courses ready, let's see a little bit the entry routes that we have to the engineering degrees. So basically, we need to start from the SEC certificate, which is basically the O-level certificate. Following that, students would be able to follow the sixth form or the MCAST routes, where you can obtain a maths certificate in pure maths or physics. If you get a grade C or better in these two subjects, then you will be able to follow directly into the Bachelor of Engineering course. If for some reason or other you don't have a grade C or better in any of the pure maths or physics, in either one of them or in both of them, then you can follow what is known as a certificate in engineering sciences, which is basically a foundation level course which tops up the knowledge in these two subjects and makes the student able to follow the Bachelor of Engineering degree. The certificate in engineering sciences is of a year-long duration. If you have an A-level pass in a science subject, but not in both pure maths and physics, so for example, you studied at sixth form pure maths and computing, or physics and computing, or any other combination, as long as you have one science subject pass at A-level, you can also follow the certificate in engineering sciences if you are interested in becoming an engineer. If you have an NQF qualification in an engineering domain from any post-secondary source, then you can also follow the certificate in engineering sciences and be eligible to follow the Bachelor of Engineering degrees. In a nutshell, the engineering career is a satisfying and exciting career for anyone who has an interest in science and maths. It's important that our engineering students are interested in working with mathematics and comfortable in working with mathematics, because as I said in the very beginning, the foundation of the courses is mathematics. But besides that, engineering students need to be the type of students who enjoy solving problems, and want to be creative in their way of solving problems. Most of the time, the work that we do, that we would eventually be doing, is work that is intended to make people's lives better. So the engineering career provides our students with the possibility of eventually working to better and enhance the quality of life of humankind. And with that, I am ready from the presentation that we had prepared for you. I will stop the recording.